Hello guys, welcome back to Techdose, and in this video we will see a very frequently asked question in the interviews, which is the subset sum problem. We will first see what the problem is, and then we will solve it by using backtracking, and finally by using the efficient dynamic programming approach. So let us see what the problem really is. We are given a set of non-negative integers as well as a sum value, and we are required to find if there exists a subset in our given set such that the sum of the elements of the subset is equals to the given sum value. Let us take an example and understand. Let us say we have the set as 2, 2 and 3. We have 3 elements in the set and the values are 2, 2 and 3. We are given a sum value of 5. Now is it possible that if we take a subset from the given set, then the sum of the elements is equals to 5? Yes, the answer is true. We are having a subset as 2, 3 from this given set, which if we add the elements, then it will come out to be 5. So this is the entire problem. We need to just say whether it's possible or not. Let us now see how to solve this subset sum problem by using the backtracking approach. So this is the recursive formula for the backtracking approach. For every element in our set, we have taken an example of set having 3 elements as 1, 2 and 3, and the sum to be found is 5. Now as soon as we move to the first element, it has 2 choices. Either we can include this in our final subset or we can exclude it. So every element will have 2 choices, and that is what is suggested by this recursive formula. Is subset sum set, that is the set of elements, n is the number of elements in this set, and sum is our given sum which is required to be found. Now if we do not include the current element, we are actually starting from the last element. Okay, this recursive formula suggests that we are starting from the last element. Now what we can do is, in order to find this sum, in order to find a subset whose element sums up to this 5, in order to find it, we can either include this element or we can exclude the current element. Okay, so if we are excluding this element, then what will happen? We will move on to the previous element, then we will decrease the number of elements by 1. Okay, so that is why we have written n minus 1, while the sum will still be the same because we have not included this element. But if I include the current element 3, then what will happen? We will decrease the number of elements in the set because we will move on to the previous element by including this, and when we include this, then the sum required will also decrease. And by how much it will decrease? In this case it will decrease by 5 minus 3, which will be equals to 2. That is sum minus set at n minus 1. Okay, so this is the basic recursive equation. This is basically not including the current element, and the second one is actually including the current element. Every element has 2 choices, and this is a logical OR symbol. So let us understand this concept by using a simple tree diagram. Okay, so what we have is, we have set as 1, 2 and 3 elements and sum as 5. So let me write this 1, 2 and 3 separately. Let us start from the left hand side. Just for simplicity, I will start from left hand side. Okay, then if I draw a tree diagram, then if I take this first element, then it will have 2 choices. Either I can include this element 1 or I can exclude this element 1. Let us say I have included this element 1, and by the way, the sum which was to be found initially was equals to 5. Okay, so now if I include this for first element, which is equals to value 1, then the sum value which is to be found will be equals to 4, because it will decrement by this value which we have included. Okay, so now we will move to the right, and at right we have 2. So we have node 2 here. Now node 2 will also have 2 choices. Either I can include this node 2 or I can exclude this node 2. Let us say that I have included this node 2. Then what will happen to sum? Sum will again decrease by the value 2, and it will be equal to 4 minus 2, which will be 2. Okay, after including this 2, we will move to right, and it has 3. Okay, so we have element 3 here. Now element 3 will again have 2 choices. Either I can include it or I can exclude it. You can see that sum to be found is less than the element here. So I cannot include 3. I will have to definitely exclude 3. So when I exclude 3, you can see that I will run out of elements. There are no other elements. Okay. So finding this sum is not possible by following this given path. So what I will do is I will just backtrack from this 3. So what I will do is I will backtrack from 3 to 2. And at 2 I know that by including this 2 I cannot find the sum. So what I will do is I will follow the another path. I will just exclude this 2. By excluding this 2 I will again have the sum to be same because I am not including 2. And I have the element as 3 here. Now 3 has two options, either I can include it or I can exclude it. Let us say I have included it. After including this 3, I will have some value left as 1 because I will decrement 3 from this some value 4 because I have included this 3. So some value will be equals to 1 and now I have no other elements left after 3. Therefore, I cannot include 3. Now if I exclude 3, then the sum value will still be 4 and there are no other elements. Therefore, I cannot include this and therefore I cannot exclude this 3. Okay. So there are no other paths. Therefore, what I will do is I will just backtrack from this 3 to this 2. Okay. So I know that either by including this 2 or by excluding this 2, it is not possible to find the given sum 5. So I will backtrack from this 2 to 1. After coming to 1, I already know that if I include this 1, then I will not be able to find any subset which will sum up to 5. Okay. So what I will do is I will just exclude this one and let us just explore whether we can find a subset whose sum will be equals to 5. I have excluded this one, so the sum value will again be 5. Now I have element 2 next. We had started from 1. Now we have element 2. Element 2 will again have two options, either to include it or to exclude it. Let us say I have included this element 2. Then what will happen? Our sum value will be equals to 5 minus 2, which will be 3. Okay. And now the next element is 3. Now after coming to this next element, it will have two options, whether to include it or to exclude it. Let us say I have included it. When I include this 3, then the sum value will be equals to 3 minus 3, which will be equals to 0. And as soon as the sum value is equals to 0, what happens is actually we have found a subset whose sum adds up to the given sum value. And what we need to do is we need to follow this given path. Let me show you the path. We need to exclude 1. So when I have the given set 1, 2 and 3, we need to exclude this 1. We need to include this 2. We need to include 2. And at 3, we need to include this 3. You can see that it is I. Therefore, our final subset, the answer becomes a subset 2, 3. And by taking this subset, we can find the given sum 5 from the given set 1, 2 and 3. Therefore, it is possible to find and it will be true. So I hope you have understood the backtracking approach. The problem with this approach is that it takes a lot of time. So the time complexity of this approach is exponential and it is actually a power of 2 when it comes to a binary tree. It is exponential. We do not have so much of computing time. Therefore, what we will do is we will have to optimize it. And an optimal approach is by using dynamic programming method. So let us now see the efficient approach by using dynamic programming. Let us take a new example and see. We have the set as having 3 elements 2, 2 and 3 and the sum to be found is 5. Okay. And we will solve it by using a dynamic programming method. Now what we will do is we will construct an array which is DP. It is a 2-dimensional array. And it will be equals to n plus 1, where n is the number of elements in the set. Here it is equals to 3, therefore I will have 4 number of rows. And how many columns do I want? I want sum plus 1 number of columns. Okay. So since sum is 5, therefore I have 6 number of columns. Now just start filling up this entire table. And whatever comes in this lower right hand corner will be our answer. Okay, this will give our answer whether we can find sum 5 by including all the elements of this set. Okay, if we have all the elements of this set, then can we find element 5? The column here shows the sum value. Let us say we are taking this 2. then is it possible to find this sum 2 by including, let us say, the first element or the second element or the third element? This is what is suggested. These columns are basically the sum values and the rows are basically including the number of elements. 0 means we have not included any element from our set. Okay, so I have a set having 3 elements, 2, 2 and 3. So here you can see that if we are required to find a sum value of 0, then we do not need any element. Okay, so it is always true that we can find a sum value of 0. So we will fill it up by true, because let us say that if you have one element in your set, then what you will do is you will just exclude this one element and you can say that I can find a sum value of 0. Similarly, if you have, say, 2 elements in your set, 2, 2, then what you will do with that, you will just exclude those 2 elements and you can still find this sum 0. Okay, so it is always possible to find sum 0. Either you have any elements or you don't have any elements. Okay, so this will always be true. And now if you have no elements, this 0 suggests that you have number of elements equals to 0 from your set. If you have no element, then you can only find a sum value of 0 and no other value. So if you are required to find, let us say, 1, 2, 3, 4 and 5, then they will all be false. So therefore, before starting this algorithm, I will fill this up, the first row and the first column. Okay, so I hope you have understood this step, and let us now move on to the next step. Let me write the set clearly. Now I have just the first element. I have included just the first element. Okay, so the number of elements are 1 in this row, in the first row. Here it is saying that can we find a sum value 1 when we have only the first element of the given set? You can see that we have two options. Either we can include this first element or we can exclude it. Let us say that we are excluding this first element. Then when we are excluding this first element, then can we find this sum 1 by having the number of elements as 0? You can see that it is false. It is false. Therefore, by excluding this, we cannot find the sum value. Okay, now we had an OR option. You can see that in the recursive formula we had two options, whether to include the element or we can exclude this element, and that was divided by a logical OR. So here, by excluding this first element, we cannot find it. What happens if we include this first element, which is 2? Since 2 is larger than this sum to be found 1, so it cannot be found. Therefore, it will be false, and false or false will be equals to false. Therefore, this will come out to be false. Now let us move on to the second column. We are required to find a sum 2. Can we find a sum 2 without including this element, the first element? It is false. You can see that if we have number of elements to be 0, we cannot find 2. So it is false. So here comes false. And if I include this first element 2, can we find the sum value to be 2? Then what we will do is, we will have to subtract. When I include this 2, then the sum value will be equals to, sum equals to 2 minus 2 will be equals to 0. So we will move to column 0. And under column 0, we will move this row by 1. Because this we have already included. So excluding this, can we find this sum value equals to 0 when we have 0 number of elements? Yes, it's true. Therefore, it will be equals to true. And false or true will be equals to true. Why are we doing this step? You should look at it very clearly. Actually, what we are doing is, we were required to find this sum equals to 2. And we had only the first number element, which is equals to 2. We had two options, either to include it or to exclude it. Let us say we have excluded it. Then when I exclude it, what happened is, can we find this 2 by using 0 number of elements? It was false. Okay, then we will include it. By including it, you can see that when I include it, then the sum required will be decremented by the value, which will be equals to 2 since I have included 2. Therefore, the sum to be found was 2, and now I will decrement 2 from it, and therefore the sum will be equals to 0. And you already know that 0 will always be found whatever the number of elements be. What we will do is, we will decrease the number of elements by 1. That means we will move one row above, and we will move to the left by the size of this first element. Size of the first element was 2. Therefore, we will hop by 2 elements. and we will look at this cell. It is saying true. Therefore, I have put here true. So false or true will be true. Therefore, I will put here true. If you are not understanding it, then you should look at the entire table. When I fill it up, then I am sure that you will definitely understand. So let us not waste time and fill this table up. When I have sum 3, then can we find it if I do not include this first element? Here it is saying that we cannot find it. Here it is false. Therefore, the first option is false. Now for the second option, when I include this value 2, then what will happen is, if I include 2, then the sum to be found will be 3 minus 2, which will be equals to 1. So I will move on to column 1 and we will move above, that is number of elements will be decremented by 1. That means 1 row up and 2 columns to the left. And we will see this. It is saying that we cannot find a sum 1 when you have 0 number of elements. Therefore, it will be false. And so this will be equals to false. This will not be true, it will be false. So it will be false. Now when we are required to find a sum 4 by not including this first element, it will be false. Okay, so the first option will be false. And when we are including the first element, then the sum value will decrease by 2, since the value of this first element is equals to 2. Here it is 2. Okay, so we will move to the left by 2 hops and we will reach here 2. And we will again move above. That means we will move to the above row, because we are just decrementing the number of elements. When we have already included this first element, then we will just exclude this and find out whether we can find this sum 2 by having number of elements as 0. And here it is saying that false. Therefore, we cannot find 4 by using the first element, and so it will be false. Similarly, this 5 will also be false. You can try it out. Now let us fill up the next row. Now as soon as we move on to the next row, what we have is, we are having 2 number of elements. So these 2 elements we will be having, and the 2 elements will be 2 comma 2. Now let us see whether we can find the required elements. Now what is happening is, we are required to find a sum 1. Can we find sum 1 by excluding the second element? It is saying that we cannot find 1 by excluding the second element. Now the second option is, if we include this second element, then can we find 1? Since this second element is greater than this sum, therefore we cannot include it. Okay, so this will be equals to false. Now as soon as I move to this sum value 2, then our first option will be, if I do not include this second element, which is 2, then can we find the sum 2? Then here it says that yes, we can find. Therefore, as soon as you see that it is true in the cell above, then what you should do is, you should blindly copy it. Therefore, it will be true, because by not including this element, this second element, we can find this 2. So we don't need to look for the other option, because we are actually using a logical OR operator, and either the left hand side or the right hand side is true, we can just write true. Therefore the first condition matches, therefore we do not need to check for the second condition. Okay, as soon as we move to the sum value 3, then can we find a sum value 3 without including this element, this second element? It is coming out to be false. Okay, so since it is false, we will check for the other option. If I include this 2, then can we find the sum value to be 3? When I include 2, then the sum value will decrease by 2, because the second element is having a value of 2. Now we will move to 1, the column 1, and we will go up a row. Okay, so we will look at this element. It is saying that it is false, because by having number of elements as 1, that is the first element, and some value as 1, we cannot find some value 1 by just having the first element, and therefore we cannot find the sum value to be 3 by having the first 2 elements. Therefore it will be false. False or false will be equals to false. Look at it very clearly. Okay, now we are moving on to 4. Okay, when we move on to 4, then can we find 4 by not including the second element? It is saying that false. We cannot find 4 by not including the second element, so this will be false. And then the second option says that if we include this second element, then can we find the sum 4? Then if we include the second element whose value is equals to 2, we will just hop back by 2 jumps. Okay, and we will move up a single row because we have already included the second element. Now we want to find whether we can find this sum 2 by including the first element, and it is saying that yes, we can find a sum 2 by including the first element. Therefore it will be equals to true. False or true will be true, so this will be true. Okay, now can we find a sum 5 by including the first 2 elements? It is saying that if I don't include this second element, then it is false. Okay, and if I include this second element, then I will just go back by 2 elements to the left and move up a row, and I will find a false. So false or false will be equals to false, and this will be filled as false. I hope you are understanding it. It is very simple and very easy. Now let us include all the 3 elements. So our set will now be 2, 2 and 3. We have included all the 3 elements. Okay, and now let us start from this one. Okay, so can we find a sum 1 when we have not included this third element? When we have not included the third element, it is saying false. Therefore we cannot find it. And if I include this third element cannot be included actually, because it is having a value 3, which is actually greater than the sum to be found. Okay, the sum to be found is 1. Therefore we will just copy from a row above. A simple trick is that if you have the current value greater than the sum value, then you will just copy from above. So you can see that I have the current value to be 3. If the sum value occurs below 3, then I will just copy it from above. So this will also be true, because I cannot include it. It will have just a single option. We will have to just exclude these 3, because including this 3 is not possible if we have some value to be lower than the given element value. Okay, we can never include it. Now when we have some value to be 3, then can we find a sum value to be 3 without including the third element? It is saying false. Okay, so first is false. If I include this third element, then can I find a sum value of 3? If I include this third element, then the value of the third element is 3. So what I will do is I will have to move back by 3 hops. So I will move back by 3 hops and I will reach 0, some value to be 0. And you can see that some value 0 can be found by any number of elements. Okay, so I will move up a row and I will have 3 hops to the left and I will find a true. So false or true will be equals to true. Therefore I can find a sum 3 by including this element, the third element of the set. Now similarly, can I find this 4, the sum 4, by excluding the third element? It is true. Therefore I will just copy it here. Okay, now can we find sum 5 by not including this third element? It is coming out to be false. Okay, now we have the second option. If I include this third element, then can I find the sum to be 5? If I include this third element, then what will happen is I will have to decrement this sum by 3. Okay, so I will hop back by 3 elements to the left. Now I have sum left as 2 and I have the remaining elements as only 2, 2. So can I find sum 2 by having just the first 2 elements? It is coming out to be true. Okay, it is coming out to be true. Therefore I will write here true. False or true will be equals to true, and therefore this will be true. So our answer is, we were actually finding whether the sum value 5 was possible from a given set. So this is our set, and is there any possible subset whose sum of elements will be equals to 5? We found that it is true. Yes, there exists a subset whose elements, if we sum them, then that will be equals to 5, and the given subset is 2, 3. Okay, so this is the entire dynamic programming method, and the time complexity of this algorithm, the dynamic programming approach, is equals to order of the number of elements, which was equals to the number of rows, into sum. Because what we are doing is we are taking the number of rows to be the number of elements. This was actually number of elements plus 1. So this one is actually a constant, therefore we don't add it. The number of rows was equals to the number of elements and the sum was actually equals to the number of columns. So the time complexity was number of rows into number of columns, that is number of elements into the sum to be found. Therefore, if the sum to be found is not too large, then the time complexity is really low. Okay, so this dynamic programming is a very efficient approach. I will post the code for both this dynamic programming as well as backtracking in the description section below, so do check it out. I hope you were able to understand this video. If you have any type of doubt, then do comment below and I will try to help you as soon as possible. Please like and share our video and subscribe to our channel in order to watch more of these programming videos. See you in our next video. Thank you.